Have you ever wondered why modern web applications feel so smooth, even when thousands of pieces of data are changing every second? The secret isn't just faster internet or more RAM, it is a clever architectural trick called the virtual DOM. In the early days of the web, every time you wanted to update a single piece of text on a page, the browser had to do a massive amount of work. It would take your entire HTML structure, reparse it, recalculate the layout of every single element, and then repaint a whole screen. This is like rebuilding an entire house just because you wanted to change the color of one single brick. It is slow, it is inefficient, and it creates a janky user experience. Today, we are going to dive deep into what the virtual DOM is actually doing behind the scenes to solve this massive bottleneck.
To understand the virtual DOM, we first need to look at the real DOM. DOM stands for Document Object Model. It is a tree-like representation of your HTML tags. When the browser loads your page, it creates this tree so JavaScript can interact with it. However, the DOM was never designed for the dynamic, highly interactive apps we built today. Every time a node in the DOM tree changes, the browser triggers a reflow. This means the engine has to check if the change affects the size or position of other elements. Imagine a long list of items. If you change the top item's height, every item below it must be shifted. This computation is the most expensive part of web rendering. The virtual DOM was born out of the need to minimize these expensive operations by acting as a middle layer between your code and the actual browser.
So what is the virtual DOM actually? It is quite simple. It is a lightweight JavaScript object that is a copy of the real DOM. Because it is just a plain object in memory, creating it and manipulating it is incredibly fast. When you change the state of your application in a library like React, the framework doesn't touch the real DOM yet. Instead, it creates a brand new virtual DOM tree representing what the UI should look like now. Think of it like a blueprint. If you want to move a wall in a house, you don't start swinging a sledgehammer immediately. You first draw it on paper. You can erase and redraw that paper blueprint 1,000 times per second without ever breaking a sweat. Only once the blueprint is perfect do you actually go and move the physical wall. The real magic happens during a process called reconciliation. Once the new virtual DOM is created, the system compares it with the previous version of the virtual DOM. This comparison is known as diffing. The algorithm looks at both trees and identifies exactly which nodes have changed. Did the color change? Did a new list item appear? By comparing two lightweight objects instead of the heavy real DOM, the framework can find these differences in mere milliseconds. It identifies the smallest possible set of changes required to update the screen. Instead of saying, re-render the whole list, the diffing algorithm might say, just change the text of the third item and make it bold. This precision is what makes modern web apps feel snappy and responsive. After the diffing is complete, the framework performs batching. Instead of sending every single change to the browser one by one, it gathers all the necessary updates into a single batch. This is crucial because every interaction with the real DOM is expensive. By grouping 50 small changes into one single update, we trigger the browser's reflow and repaint process only once. This is the final step where the virtual DOM patches the real DOM. The browser receives a highly optimized list of instructions. It is like a delivery driver who waits until they have 10 packages for the same neighborhood before leaving the warehouse, rather than driving back and forth for every single envelope. This efficiency is why you can have complex animations and data streams running simultaneously without the browser locking up. So is the virtual DOM always faster? Not necessarily. For a very simple website with only a few elements, the overhead of creating a virtual DOM and running a diffing algorithm might actually be slower than just updating the DOM directly. However, as your application grows in complexity, the benefits become exponential. The virtual DOM provides a declarative way to write code. You just tell the framework what the UI should look like based on the current state, and the virtual DOM handles the how of getting there. It abstracts away the manual, error-prone DOM manipulation that used to plague web development. In summary, the virtual DOM is a performance optimization and a developer experience tool wrapped into one, making the modern web possible. Thanks for watching.